Let us discuss foundation chemistry, chemical bonding in that Vsepr theory that we will see. Now, if covalent molecule is given, how to draw the Lewis dot symbol, how to draw the shape of the molecule, that we will see. Now we will take. We have seen homogeneous diatomic molecules means linear, heterogeneous diatomic molecules means linear. Now we will go for polyatomic molecules. For example, we will take beryllium chloride. We will take. For this molecule, what is the shape? What is the shape of this molecule? How this Vsepr theory is explaining that? That we will see. Vsepr theory in the sense valence shell, electron pair, repulsion theory. Valence shell, electron pair, repulsion theory. Okay. Now, valence shell means from this shell, electrons involved in chemical reaction. Electron pair means two electrons. Between electrons, what will possible? Repulsion is possible because electrons are like charges, therefore repulsion is possible. Okay. Now we will take beryllium. For this beryllium, atomic number is 4, electronic configuration is 2, 2. This is outermost shell. Outermost shell contains 2 electrons. This is also called valence shell. This valence shell is containing 2 electrons. That 2 electrons we will write in the form of dot. So 1 dot, 1 dot. Okay. So beryllium outermost shell, that means valence shell is having 2 electrons. That 2 electrons we have written in the form of 2 dots. Then we will take this chlorine. We will take chlorine atomic number 17. So electronic configuration is 2, 8, 7. This is, we can say, outermost shell. This we can say valence shell. This valence shell is having 7 electrons. That 7 electrons will write 1, 2, 3, 4, 5, 6, 7. Similarly, for another chlorine, 7 electrons will write. So for another chlorine, we have written 7 electrons we have written. Now we can say chlorine is in need of 1 electron to get octet. Chlorine valence shell is having, chlorine valence shell has 7 electrons. So it is in need of 1 electron to get octet. Therefore, it is contributing 1 electron. Beryllium also contributing 1 electron. Between them, a bond is possible. A bond is formed. This bond is formed by contribution of electrons by both. Therefore, this bond is called covalent bond. Then this chlorine, this valence shell is having 7 electrons. It is in need of 1 electron to get octet. Therefore, it is contributing 1 electron, while beryllium also contributing 1 electron. Between contributed electrons, bond is formed. Therefore, this bond is called covalent bond. So, in beryllium chloride, beryllium is making a 2 bonds. Beryllium is having 2 bonds, we can say. Single bond means generally we will call it as a sigma bond. This is what means single bond? Single bond in the sense generally we will call this is as a sigma bond, we will call for this symbol sigma. Okay. So in beryllium chloride, beryllium is having 2 sigma bonds. Okay. Like this is there means what is the shape means linear shape. And what is the angle? Angle in the sense angle formed between the 2 bonds. Between these 2 bonds, what is the angle formed? That is called bond angle. That bond angle is how much in the sense 180 degree. So in beryllium chloride, bond angle in beryllium chloride is how much in the sense 180 degree. The shape is what means linear shape. So beryllium chloride shape is linear. Bond angle is 180 degree, we can say. Okay, bond angle 180 degree. Okay. So beryllium chloride we said. Next molecule we'll take boron trifluoride. This BF3. B is called boron, 3 is tri, F is called fluoride. Boron trifluoride will take. In boron trifluoride, boron will take its atomic number is 5, electronic configuration 2, 3. This 3 is outer shell, otherwise valence shell. This valence shell is having 3 electrons. That 3 electrons will write in the form of 3 dots. 3 electrons we have written in the form of 3 dots we have written. Then surrounding atom is fluorine. That fluorine atomic number is 9. Electronic configuration is 2, 7. 7 is outer shell, otherwise valence shell. The valence shell is having 7 electrons. So for fluorine, valence shell has 7 dots. For fluorine, we are giving 7 dots because valence shell is having 7 electrons. So for fluorine, 7 dots we are giving. For fluorine, we are giving 7 dots we are giving. Now, fluorine is in need of 1 electron to get octet. Therefore, fluorine is contributing 1 electron, while boron also contributing 1 electron. Both are contributing 1 electron each. Between them, a bond is possible. In the same way, here one bond. Okay. Now, this is in this compound. Okay, one boron atom, and 3 fluorine atoms. That is all the atoms are in a plane. That means all the atoms are in one plane, we can say. All these atoms are in one plane, we can say. Therefore, this molecule is what in the sense planar. This molecule, what we can say, means planar, we can say. Planar in the sense all these atoms present in a plane of screen. Therefore, this molecule is planar molecule. And what is the angle? What is the angle formed here? If you see, here angle is 120 degree. Here also 120 degree. Here also 120 degree. Therefore, it is called a trigonal planar. We will call this molecule as a trigonal planar. We can say what is a bond angle means 120 degree is the bond angle. Okay. So we have said about this BF3. We said next we will take CH4. We will take CH4 is called methane. So for methane, central atom is what means carbon. Carbon atomic number is 6. Electronic configuration is 2, 4. The 4 is outer shell or valence shell. So valence shell of carbon contains 4 electrons. So we will write 4 dots for this cell. Then hydrogen atom, you know that hydrogen atom is having 1 electron because it is coming under, it is having 1 electron. Atomic number is 1. Therefore 1 electron we have written. Then we'll see this carbon. This carbon valence shell is having 4 electrons. It is in need of 4 electrons to get octet. Therefore, it is contributing 1 electron to each hydrogen. It is contributing 1 electron. Now, this carbon, okay, carbon in methane has 4 bonds. 4 bonds in the sense 8 electrons. 8 electrons in the sense octet in the sense this methane obeys octet rule. We can say methane obeys octet rule. What about the previous molecules? This molecule we'll see. Now boron in BF3 has 3 bonds. That means 6 electrons. 6 electrons means not having octet configuration. Therefore, BF3 is a electron deficient molecule. BF3 we can say as electron deficient molecule because it is not having octet configuration. What about that previous molecule, beryllium chloride? So beryllium in beryllium chloride has 2 bonds. That is 4 electrons. Therefore, not having octet. So not having octet configuration, we can say. Therefore, beryllium chloride is a electron deficient molecule. Beryllium chloride is what in the sense electron deficient molecule, we can say. So beryllium chloride is electron deficient molecule. Sir, okay. Next we will take this methane. In methane we have taken this carbon and 4 bonds are there. Now this carbon we will write and we will take out of these 2 bonds we will take. These 2 bonds are in a plane of this screen. In this screen plane it is there. Okay, let us consider these 2 bonds present in a screen of this plane. Okay, so now we are considering these 2 bonds. These two bonds present in a screen plane. Okay, then what about this bond? This bond is is rear of this screen, rear of this screen, like this we will take rear of this screen. Okay, so that is rear of the screen. Then this bond projecting, this bond projecting towards us, projecting towards us, like this is there, like this will take projecting towards us. Okay, like this is there. So the methane structure is so and so. Structure of methane is so and so. Then what is the shape of methane that we will see? Now in this methane, you join any three hydrogen atoms. You join any three hydrogen atoms, what shape you will get in the sense equilateral triangle you will get. How many equilateral triangles you will get in the sense? 4 equilateral triangles. 4 means a tetra. Equivalent equilateral triangles we are getting, therefore hedron. Therefore tetrahedron, tetrahedral is the shape for this. What is the bond angle? Bond angle is equal to 109 degree 28 minutes. Bond angle is how much in the sense 109 degree 28 minutes. Bond angle means angle between neighboring bonds. Angle between neighboring bonds is called bond angle. That bond angle is 109 degree 28 minutes here. Okay, anywhere here 109 degree 28 minutes. Between these two bonds also 109 degree 28 minutes. Between these two bonds 109 degree 28 minutes. Between these two bonds 109 degree 28 minutes. Like this will be there. Okay, so methane shape is what means a tetrahedron. Bond angle is 109 degree 28 minutes. It is obeying octet rule. So next we will take a PF5. Will take PF5. This P is called phosphorus. P is called phosphorus. This 5 is called penta, and F is called fluoride. So phosphorus pentafluoride. Now phosphorus will take, its atomic number is 15, electronic configuration is 2, 8, 5. This 5 is outer shell, otherwise valence shell. So valence shell is having 5 electrons. Okay. So we'll take P. This valence shell is having 5 electrons. Therefore, we'll write 5 dots. 5 dots. We know regarding fluorine, fluorine valence shell is having 7 electrons. Therefore, 7 dots will give. So fluorine valence shell has 7 electrons, therefore 7 dots we are giving. So for each fluorine, we are giving 7 dots because it is coming under 7th A group. It is coming under 7th A group. This valence shell is having how much means 7 electrons present. Therefore 7 electrons will give. Set. Fluorine valence shell is having 7 electrons. It is in need of 1 electron to get octet. Therefore it is contributing 1 electron, and phosphorus also contributing 1 electron. Both of them contributed 1 electron each. Therefore between them a sigma bond is possible. Single bond is possible. So like this bonds we can give. Sorry, we have given like this bonds. So now phosphorus in PF5. Phosphorus in PF5 has 5 bonds, 5 sigma bonds. That means 5 bonds in the sense 10 electrons. 1 bond means 2 electrons. 10 electrons means it is greater than octet. Therefore, we can say it is electron rich molecule. We can say electron rich molecule. In PF5, phosphorus has 10 electrons in the valence shell. 10 electrons means greater than octet. Greater than octet we can say as a electron rich molecule we can say. Then how this PF5 will be there? If you join these 3 fluorine atoms, you will get a equilateral triangle. If you join these 3 fluorine atoms, you will get equilateral triangle. Therefore, your name is trigonal is given. Trigonal name is given. Then here, if you join these 3 fluorine atoms, if you join these 3 fluorine atoms, you are getting equilateral triangle. Here, what is the angle? If you see how the angle is there means now we'll join these 3 fluorine atoms. We are joining these 3 fluorine atoms. What shape we are getting means equilateral triangle we will get. So if we join equilateral triangle, we will get, therefore here bond angle is how much in the sense 120 degree we can say. Here what is the angle means 120 degree is possible. So in PF5, what is the angle possible in the sense 120 degree is possible. So this is what in the sense it is this PF3, these 4 atoms. These 4 atoms, how it is present means, these 4 atoms means 1 phosphorus and 3 fluorine atoms. These 4 atoms present in a plane, present in a screen plane, like this will take, present in a screen plane. Then how the other 2 fluorine atoms will be there? How the other 2 fluorine atoms will be there? That means this fluorine atom is above the screen plane, above the screen plane. Above the screen plane means like this will be there. That means it will make, what is the angle in the sense 90 degree it will make. Therefore another bond angle is 90 degree. How this fluorine will be there means it is below the screen plane. It is below the screen plane will be there. Therefore below the screen plane will be there means it also makes 90 degree with this screen plane. Therefore what is a bond angle possible means 120 degree and 90 degree. Therefore since these 2 fluorine atoms, one is above and another one is below, we can say bipyramid, we can say. Okay, bipyramid. These 4 fluorine, these 3 fluorine atoms makes equilateral triangle. Therefore we can say include trigonal. Therefore the shape of this pfi molecule is a trigonal bipyramid. So to this we have to include bipyramid and we have to say trigonal bipyramid for pfi. So pfi molecule shape is a trigonal bipyramid and bond angle is 120 degree and 90 degree. This pfi comes under electron rich molecule, we can say. In this pfi, phosphorus is having 5 sigma bonds. Phosphorus is having 5 sigma bonds, we can say. Okay, next we'll take SF6. We'll take in SF6 sulfur atomic number is 16. Its electronic configuration is 2,8,6. This 6 is present in outer shell. The 6 electrons present in outer shell, otherwise in the valence shell. Okay, so sulfur 2,8,6 is the configuration. Now these 6 electrons present in the outer shell, otherwise valence shell, we can say. Now sulfur valence shell is having 6 electrons. Sulfur valence shell is having 6 electrons, we can say. Sulfur valence shell is having 6 electrons and the surrounding atoms are fluorine atoms. Fluorine atoms valence shell is having 7 electrons. Fluorine atoms valence shell is having 7 electrons, we can say. Sir, the fluorine is in need of 1 electron. Therefore fluorine is contributing 1 electron, sulfur also contributing 1 electron, both of them contributing 1 electron each. Between them bond is possible. So like this all the fluorine atoms making bond with sulfur atoms like this. So we got what in the sense SF6. In SF6 sulfur has 6 sigma bonds. 6 sigma bonds. 6 sigma bonds means that is 12 electrons. 12 electrons means greater than octet. Therefore this SF6 is a octet rich molecule. Octet rich molecule, that means a electron rich molecule, we have to say. This SF6 we can say as a electron rich molecule. Okay, greater than octet, therefore electron rich molecule, we can say. Set. In this SF6, how these 4 fluorine atoms and this sulfur will be there, that we'll see. Okay, in this sulfur, it is 1 fluorine, it is 2nd fluorine, it is 3rd fluorine, it is 4th fluorine. How it is there means like this. So if you join this, you will get a square planar. Okay, these 5 atoms, these 5 atoms in the sense 1 sulfur atom and 4 fluorine atoms. These 5 atoms present in a square plane, present in a square plane of this screen. Okay, these 5 atoms present in the screen plane and makes what shape in the sense a square shape. Therefore it is a square planar, we can say. So square planar in the sense here what is the angle possible? 90 degree possible. Therefore bond angle is how much in the sense 90 degree, we can say. Then how the other 2 fluorine atoms present means this fluorine is present above this screen plane, above screen plane it is present. Above screen plane means it is perpendicular to the square planar, therefore it is making 90° with this. Okay, so bond angle is 90°. This is present below screen plane. It is present below screen plane, so it is also making 90° with this square planar, therefore bond angle is 90° we can say. Now, so one fluorine is present above screen plane we can say. Now you join this fluorine with any two of these two fluorines, any two fluorines from these four. You join this above fluorine with any two fluorines of this, any two fluorines of this. What shape you will get? In the sense equilateral triangle you will get like this. How many equilateral triangles you will get? In the sense four equivalent equilateral triangles you will get. Four equivalent equilateral triangles you will get here. Similarly, this below fluorine is making a equilateral triangles with this square planar four fluorine atoms. Therefore, totally 8 equivalent equilateral triangles possible. Therefore, 8 in the sense octa equivalent equilateral triangle. Therefore, hedron. So octahedron. So shape is octahedron. So SF6 shape is what means octahedral shape. What is the bond angle? In the sense 90° we can say. Set. Next we will take a IF7. We will take IF7. Iodine valence shell contains what means 7 electrons, because it is coming under which group? In the sense it is coming under 7th A group. It is coming like a fluorine group. It is coming under fluorine group. Therefore, fluorine is having 7 electrons in its valence shell. It is also having 7 electrons in its valence shell. Therefore, 7 dots we can give for a iodine. Iodine valence shell is having 7 electrons. Fluorine valence shell also having 7 electrons. Fluorine valence shell having 7 electrons. Iodine valence shell also having 7 electrons. Why? Because fluorine and iodine both come under same group. Therefore for fluorine valence shell contains 7 electrons we can say. Fluorine valence shell contains 7 electrons. Okay, they are making bond here. They are making bond here, one sigma bond, here one sigma bond, here one bond, here one bond. They are making bonds like this. Okay, they are making bonds like this. Now we can join these 5 fluorine atoms, 1 and 2, 2 to 3, 3 to 4, 4 to 5, 5 to 1. It is pentagon. It is what means pentagon. Pentagon. This fluorine and this fluorine gives a bipyramid. Bipyramidal, that means pentagonal bipyramidal. Pentagonal bipyramidal is the shape for this molecule. Okay, here central atom is what? In the sense iodine. So iodine in IF7, iodine in IF7 has 7 sigma bonds. 7 sigma bonds, that is 14 electrons. 14 electrons means greater than octet. Therefore, it is a electron rich molecule. It is what molecule? In the sense electron rich molecule we can say. Therefore, IF7 comes under which category? In the sense electron rich molecule we can say IF7. Okay, the shape is what? In the sense pentagonal bipyramid. Okay, next molecule we'll take the molecule called ammonia. Ammonia we'll take. Ammonia formula is what? In the sense NH3. We are taking the molecule ammonia. We are taking ammonia formula is NH3. Here central atom is nitrogen. Nitrogen atomic number 7. Electronic configuration is 2, 5. So this outermost shell is having 5 electrons. Valence shell is having 5 electrons. So nitrogen valence shell has 5 electrons. Those 5 electrons we will write in the form of 5 dots. Okay. Surrounding atoms are what? In the sense hydrogen. Hydrogen atomic number is 1. Therefore, hydrogen atom is having 1 electron. Okay, now bond is possible. Bond is possible. Now these 2 electrons. Okay, these 2 electrons present in the valence shell of nitrogen. Valence shell of nitrogen, but not involved in bonding. But not involved in bonding. Therefore, they are lone electrons. They are lone electrons. two lone electrons present, therefore it is a lone pair. It is what in the sense lone pair. Okay, so nitrogen in ammonia has one lone pair and three sigma bonds, that is one lone pair means 2 electrons, three sigma bonds means 6 electrons, totally 8 electrons. 8 electrons means obeys octet rule. Obeys octet rule, we can say. Obeys octet rule. Okay, ammonia is obeying octet rule. So what is the shape of this ammonia? What is the shape of this ammonia in the sense? Ammonia shape is a pyramid. Ammonia shape is what in the sense? Pyramid. What is the bond angle possible here in the sense? 107 degree is the possible bond angle. That means between these two bonds, angle is 107. Between these two bonds also 107. Between these two bonds also 107. 107 degree is the bond angle for ammonia, we are saying. Okay. Next molecule will take water. In water, oxygen is the central atom. Its atomic number is 8. Its electronic configuration is 2,6. The 6 is a outermost shell or valence shell. So oxygen valence shell is having 6 electrons. Oxygen valence shell is having 6 electrons, we can say. 6 electrons present in the valence shell of oxygen. Hydrogen atom, if you take, that is having 1 electron. Hydrogen is having 1 electron. Now they are making bond like this. So it is lone pair, it is also lone pair. So this oxygen is having 2 lone pairs here. Okay. So oxygen in water has a two lone pairs and two sigma bonds. Two sigma bonds. Therefore, 8 electrons present here. 8 electrons means obeying octet rule. So we can say obeying octet rule. We can say obeying octet rule. Then what is the shape of this water in the sense V shape? Like V is there, no? Therefore V shape, otherwise angular shape, otherwise bend shape. What is the bond angle in water in the sense 104.5 degrees is the bond angle set. So we have discussed about what in the sense water molecule we discussed. Then we will take OF2 molecule, we will take OF2. This oxygen valence shell has 6 electrons, therefore we will write 6 dots, we will write for OF2. Oxygen we have written. Fluorine valence shell is having 7 electrons, therefore this we will write 7 dots. For fluorine we have written 7 dots. These two electrons make a bond, and here also bond is formed, therefore it is lone pair, Therefore in OF2, oxygen is having how many lone pairs? Means 2 lone pairs and 2 sigma bonds are there. Therefore, its valence shell is having 8 electrons. 8 electrons means obeying octet. This shape also similar like water. Therefore, OF2 we can say bend shape, otherwise V shape or angular shape we can say. For OF2, we said what is the shape we said. Okay. We'll take next molecule. Next molecule, what in the sense CHCl3. CHCl3 is called a chloroform. So how chloroform is there? We'll see carbon atomic number 6, electronic configuration 2,4. 4 is the outermost shell or valence shell. So carbon valence shell contains 4 electrons. Carbon outermost shell contains 4 electrons. Then one place hydrogen will give, hydrogen is having 1 electron. Cl will give, Cl is having 7 electrons in the valence shell. Cl is having 7 electrons in the valence shell. Now here bond is possible, here bond is possible, here bond is possible, here bond is possible. Okay, in chloroform, in this chloroform shape is what? Means CHCl3, surrounding atoms 1 hydrogen and 3 chlorine atoms. This is what shape in the sense it is similar like methane. Therefore here also we can say tetrahedron. We can say tetrahedron. We can say tetrahedron is the shape. But here what is the thing? Means surrounding atoms are not similar. Therefore, the shape is slightly distorted, so that we can say distorted tetrahedron. Distorted in the sense getting irregularity, not perfect, not regular. Okay, this we can say distorted tetrahedron, we can say. Which one? This chloroform. Okay, next we will take methylene chloride. Next we are taking methylene chloride, we are taking methylene chloride or methylene dichloride, we can say. Here central atom is carbon. This valence shell is having 4 electrons. Therefore, we will write 4 dots. We will write, and 2 hydrogens are there. Hydrogen is having 1 electron each. Then Cl will take. Cl is having 7 electrons in its valence shell. Cl is having 7 electrons in the valence shell. Now they are contributing their electrons and making bond. Now carbon in methylene chloride, otherwise methylene dichloride. Carbon in methylene dichloride is having 4 sigma bonds. 4 sigma bonds means 8 electrons. 8 electrons means obeying octet rule. Obeying octet rule, we can say. This is about what in the sense methylene chloride. Next we will take CH3Cl. CH3Cl is called what in the sense methyl chloride, we can say methyl chloride. In this methyl chloride, central atom is carbon. It is having 4 electrons in its valence shell, and 3 hydrogen atoms are there, and 1 chlorine atom is there. They are making bond. Here 1 bond, here second bond, third bond, fourth bond. It is called distorted tetrahedron. It is also obeying octet rule. Next we will take carbon tetrachloride, CCl4. This is called carbon tetrachloride. Carbon tetrachloride, CCl4. Here central atom is carbon. It is surrounded by 4 chlorine atoms. 4 chlorine atoms. So 4 bonds is possible. This is a perfect tetrahedron, we can say, because surrounding atoms are similar. Perfect tetrahedron. It is also obeying octet rule. This also obeying octet rule because valence shell of carbon is having 8 electrons because of 4 bonds. So next we will take the molecule. What in the sense BRFI. BRFI will take. Now here central atom is bromine. Bromine, surrounding atoms are fluorine atoms. Those fluorine atoms you will write. Those fluorine atoms you are writing. Now bromine comes under the group of fluorine. Therefore bromine valence shell is having 7 electrons. Therefore I will give 7 dots. 7 dots we are giving. Now each dot is making bond with fluorine. Each dot is making bond with fluorine, we can say. Sir. Now this BRFI, what is the shape? What is the shape of this BRFI in the sense square pyramid? Square pyramid, we can say. In this square pyramid, central atom bromine is having 1 lone pair and 5 sigma bonds. Therefore, totally 12 electrons. Therefore, we can say electron rich molecule. We can call this as electron rich molecule. BRFI is coming under electron rich molecule, we can say. Next we will take ClF3. We will take ClF3. Chlorine we have written. This valence shell is having 7 electrons because it is coming under 7th A group. That means fluorine, chlorine, bromine, iodine, astatine all are in same group. It is making bond with the fluorine. It is making bond with the fluorine. It is making bond with fluorine. It is looking like T shape. Therefore, shape of this molecule is T shape. This is also in this chlorine in ClF3. Chlorine in ClF3 is having 2 lone pairs, 3 sigma bond pairs, totally 10 electrons. Therefore, electron rich molecule. Therefore, ClF3 we can call it as a electron rich molecule, we can say. Okay, because its valence shell is having 10 electrons. So that, okay. Next we will see. Next we will take a xenon. Will take xenon is noble gas compound. It will not make any compounds, but under certain conditions it is making compounds. What is the compounds means XeF2. Now XeF2 will take XeF2 we have taken. Xenon valence shell is having 8 electrons. Xenon valence shell is having 8 electrons. That 8 electrons I will give in the form of dots. So if one electron is making bond with one fluorine, another electron making bond with another fluorine. Now we can say xenon in XeF2. Xenon in XeF2 has 3 lone pairs, and 2 sigma bonds. Therefore, totally 10 electrons. 10 electrons in the sense electron rich molecule. XeF2 is electron rich molecule, we can say. XeF2 shape is what in the sense linear shape, and bond angle is what in the sense 180 degree, we can say. Next we will take XeF4. XeF4 means xenon will take. This valence shell is having 4 electrons. Therefore, 4 electrons plus 4 electrons, totally 8 electrons. Here 2 lone pairs are there. Now it is making bond with the fluorine. It is also fluorine. It is making bond with the fluorine. Here fluorine, we can say it is a square planar. Square planar, we can say square planar means bond angle is 90 degree, we can say. In this one, in this XeF4, xenon in XeF4 is having 2 lone pairs, then 4 sigma bonds, therefore 12 electrons it is having, therefore electron rich molecule, we can say. It is a electron rich molecule, like that we can say. Next we will take XeF6. In XeF6, xenon is there. This valence shell is having 8 electrons. That 8 electrons we will write in the form of dot. So 8 electrons we have written in the form of dots. Each electron is making bond with the fluorine. Therefore 2 electrons will be remaining. That is called what in the sense? That is called lone pair. Now xenon in XeF6. Xenon in XeF6 has 6 sigma bonds and 1 lone pair. Therefore, it is a electron-rich molecule, we can say. This shape is what in the sense distorted octahedral. This shape is what in the sense distorted octahedral, we can say. Distorted octahedral, we can say. So far, what are the things we have discussed? So far, we have discussed valence shell electron pair repulsion theory. We have discussed. Then we have discussed electron deficient molecule, electron rich molecule, obeying octet rule we discussed. Then shapes of molecules and bond angles of molecules we have discussed. Then we said sigma bonds and lone pairs we said. In some cases central atom is having only sigma bonds. In some cases central atom is having sigma bonds and lone pairs present. Okay. Let us complete the class.